Very good morning to all. Once again, we welcome you all to the 5 days FTP sponsored by ATAL. Today, in this, we are at the last day and we are in the second session. So, in this session, we welcome Dr. Kalpana from AATM Kanjipuram to deliver the lecture on IoT and blockchain technology in the application of Industry 4.0. We welcome you, ma'am.
Thank you, sir.
And it is I am very happy to introduce our expert, Dr. Kalpana Madam. She is working as an assistant professor in AATM Kanjipuram, and she had completed her doctorate degree from IIT Madras. And her research interests are operation research, supply chain coordination, logistics and distribution, and transport networking, scheduling and forecasting, and Industry 4.0. It is our great pleasure to have you, and I request you kindly go ahead of the session.
Okay, sir. Thanks for the introduction. I'll move ahead. Shall I share my screen, sir?
Please, ma'am. Please, you can.
So for the time being, I'll turn off the video.
Yes, ma'am. No
issues. The internet connectivity issue.
Yes, ma'am. Yes, ma'am.
So is it visible?
Yes, ma'am. Visible, ma'am. Please, you can go ahead.
Yeah. So good morning, everyone. So today's topic is for this session. My topic is IoT and blockchain, the emerging technologies transforming the world. Okay. Sir has already introduced me, and before I joined in AATM in April 2019, before that I was working with Ramco Systems as operations research consultant for 3 years, and after that I joined with Ford Motor Company as operations research expert from October 2016 to March 2019, almost 2.5 years. And prior to my PhD, I was working as a teaching. I was in teaching profession almost for 2.5 years, and the research interest already sir told. And now I will move to the presentation. Okay. And so in the slide, you can see the statement given by our Honorable Prime Minister, Mr. Narendra Modi. He said, emerging fields including artificial intelligence, machine learning, Internet of Things, blockchain, and big data can take India to new heights of development and improve the quality of life of its citizens. And so this is not an industrial transformation, but it is a social transformation. In addition, he added, Internet of Things and blockchain will help India to address various challenges existing in different domains like education, healthcare, and agriculture, job creation, and environmental sustainability. Okay, so in this session, we are going to discuss about the various applications of Internet of Things in Industry 4.0. So this term is a trending term in digital revolution. So you may have heard of this term, or you may have used this term in your project. And this term was actually coined by Kevin Ashton in 1999. But before this, the concept of so actually Internet of Things actually makes things smarter by connecting different devices, okay, through internet. And this was coined during 1999. The concept of connecting devices exists during 1830s itself. For example, connecting machines, electric telegraphs, and voice transmission, and then we can say SCADA, and then wireless technologies. So all these technologies helps to connect machine to machine. But the difference is it connects. It is mainly used for data transfer. But the thing is, the Internet of Things not only connects the machine, but it also retrieves data from the devices. Wherever it is connecting the devices through internet, it is receiving, collecting data from those devices. We will see those things. What are the advantages of collecting data, and all those things we will discuss in the upcoming slide. And so whenever you are talking about the Internet of Things, you cannot separate the concept of data analytics. Okay, so without data analytics, there is no use of Internet of Things. Okay, and along with this data analytics and Internet of Things, we are going to discuss the concept of blockchain, how this blockchain concept help to enhance the operations of Internet of Things. Okay, so all these things we are going to discuss at the high level. And so before going into the discussion on Internet of Things, I'll quickly take you to understand the industry revolution. Okay, so today morning only I saw the list of topics. So I came to know that there is a topic on IIoT. So some of the slides may be similar. You can apologize me. Okay, and before during this 16th century, people used to produce products by using handicraft method. Okay, so here they mostly employed one or two people to complete the entire task, to complete the entire product. They don't have any mechanized parts or tools to fabricate their machines. And so during that time, they were managing producing products by handicraft method because the demand for those products are very, very less. But over a period of time, the product demand has increased. The demand for the products has increased. Nothing like anything. So to manage all these things, the concept of factory developed. So during this industry 1.0, so during that time, machines, larger machines were introduced to produce many products. And so in starting of 18th century, most of the machines were operated by steam power. One of such invention is weaving machine. Okay, so if you look at the production rate of weaving machine when compared to the machine which was operated by hand, the production rate was 8 times more than the traditional machine. Okay, steam powered engine machine produced 8 times more than the manually operated weaving machine. And during the starting of 19th century, the electric energy instead of steam power, factories started to introduce electric energy to operate their machines. So during that time, so this revolution is called as technology revolution. And during this time, Henry Ford, who was the founder of Ford Motor Company, so he introduced the concept of mass production. Okay, and so mass production as well as moving assembly line. So this is one of the biggest contribution of Ford Motor Company for Industry 2.0. And moving to the next revolution, in 70s of 20th century, slowly we moved into digitalization. Okay, slowly some of the repetitive or tasks which don't require manual intervention were automated. So slowly we entered into some partial automation, and through CNC machines and computer algorithm operated things, we slowly entered into digitalization. And over a period of time, partial automation was converted into fully automation. But still, in some manufacturing companies are still using manual assembly as well as manual production system. Okay, they are operating the machine to produce the product. And so here automation was introduced in industry 3.0. Okay, industry 3.0 automation was introduced. And now we are in industry 4.0. So here with the help of this Internet of Things, so the principle is connecting devices through internet. So because of this, we are able to connect machine to machine. Okay, and we are able to retrieve the data from the machine for various purposes. Those things we will discuss in the upcoming slide. And so now the difference from industry 3.0 and industry 4.0 is, one thing is we are able to connect the machines. Not only machines, we are able to connect different devices. Okay, and one more difference we could say is along with automation, now we have brought intelligence into the machine. Okay, so the major difference in industry 4.0 is bringing intelligence into the systems, various systems. Okay, and this Internet of Things is the key enabler for this thing, from automation to autonomous. Okay, and in industry 4.0, there are many components constitute industry 4.0. Okay, Okay, not only Internet of Things. So the other components which constitute Industry 4.0 as listed here, it is autonomous robots, simulation, cyber security, cloud computing, additive manufacturing, augmented. So all these things constitute Industry 4.0. And in this presentation, our scope is discussing about Internet of Things. And along with that, we are going to discuss about the benefits of blockchain in Internet of Things. Okay. So am I going fast?
Please, you can go comfortably. Oh.
Okay. So now let us discuss the basic principle of Internet of Things. Let us take a small example. Let us take this example of mobile phone. 20 years back, we had mobile phone, but with that mobile phone, we can do only two things. One thing is we can simply talk. We can communicate. We can communicate to other persons. And the second thing we can do is we can simply send some text messages. So those are the only two things that we could do with the help of mobile phones 20 years back. So now we mostly all have smartphones. Okay, so what is the reason why do we call it as a smartphone? So now the things become smarter. So the reason for this is now in addition to speaking as well as sending text messages, now we are doing all kind of operations through mobile. Okay, including watching music and then checking mails, sending video files, sending audio files. So all things. Similarly, counting number of steps while during walking. So all these things we can able to do with the help of mobile phones. Okay, now the mobile phone getting smarter after it is getting internet connection. Okay, similarly, we can say that when objects or devices can become smarter while connecting those objects with the internet. Okay, so the reason for connecting objects to internet is enable communication between devices. That is one thing, and we should understand the reason for why should we connect the devices through internet, and what is the benefits of enabling communication between devices. So that is very important. Okay, so the main thing is we have to improve the efficiency of the existing system by communicating by enabling communication between devices as well as by collecting the data from the devices. That is important thing. By collecting the data between the devices and then sharing the data across different stages, different portions of the system. Okay, and so what is the use of collecting data? Now the question is, what is the use of collecting data? So obviously it is mainly used for automation and for taking important decisions based on the performance of the devices. We can optimize the existing process, or we can automate the process, or we can take some informed or data driven decisions. So these are all some of the important benefits that we should get by connecting the devices through internet. Okay, and so one such example is suppose if you have IoT enabled manufacturing system, then you can say that you can continuously monitor the performance of the machine, and if anything happens wrong, immediately it will be intimated to the concerned person. Okay, so immediately the rectification will be done. So all these things we can perform by enabling your system with Internet of Things. Similarly, you can study about your system, and you can understand the pattern how it is performing, and you can predict the behavior of your system. So all these things you can do. And some of the examples are listed here. One is connected appliances, so which is predominantly used in your houses. Okay, smart microwaves. In this case, so the automatic cooking will be done based on your prerequisites. Like if you are saying that the food should be cooked for this much of time, automatically the food will be cooked. And the second thing is self-driving cars. So here I should not tell self-driving cars, it is connected vehicles. We could say connected vehicles. So in connected vehicles, most of the critical parts are connected through internet, and so this is used for many purposes. Okay, one thing we can say is it should monitor the driver behavior. So how the driver is behaving while driving the car. So based on that, the system could suggest some suggestions to the driver. So one application we could say predicting the driver behavior, and the other thing is So since this IoT devices are embedded in critical parts, so those parts will continuously monitor the performance. So if anything goes wrong, it immediately informs to the OEMs. Okay, it immediately informs the OEMs or the service centers, which is nearer to the current location of the vehicle. Okay, and then so based on that, the uh, service center may arrange for or may allocate slot for the repair of this vehicle. Okay, maintenance for this vehicle. And then wearable health monitor. So this we are well known. We have smart watches, which measures various parameters from us in terms of number of steps we are walking, what is our heart rate, heartbeat rate, blood pressure. So all these things are monitored, and based on the parameters measured, it will suggest you um, uh, it will give you some suggestions based on your fitness of your health. And then the other things, wireless inventory trackers and the biometric cyber security scanners, shipping containers and logistics tracking systems. So these two things we will discuss in detail in the upcoming slides. And so as I said in the previous slide, so the main purpose of this IoT is it has to retrieve the data, and it has to analyze the data. Based on the analysis, it has to give some decision making, right? So here, if you take any internet platform, in general, it has 4 layers. The first layer is sensor layer, so in which the sensors are actually connected to the physical devices. Okay, physical devices of interest. Okay, it could be manufacturing system, or it could be health, it could be healthcare industry. So anything, it could be anything. And so once the devices are embedded into the system of interest, then the data whatever we are receiving will be transmitted to the cloud storage through this network layer. So the second layer is called as network layer. So through this layer, the collected data from all these sensors will be transmitted to the cloud storage, where the data is stored. And along with this storage, we have the required algorithms and analytic tools. So by using these algorithms and analytic tools, the respective operations analysis are performed, and based on the output of this analysis will be after that. The third layer consists of cloud storage, analytic tools, and then some other software system which integrates different devices to the cloud. This is called platform layer, and the last layer is application layer. So based on the output which we got from analytics or some other tool, it will be sent to the respective applications. Yeah, the applications could be an app, or it could be websites, or some other thing. So these are the 4 basic layers the general IoT has, and actually the data whatever we are collecting through this devices, right? So it is transmitted to this network layer through this gateway. Okay, so we cannot directly transmit the data whatever we are receiving from the devices of interest to the network layer. So through gateway only we can transmit the data. And so look at this picture. So here I said through gateway only we can transmit the collected data from the devices, right? And the whatever data we are collecting through the sensors are in analog form. We cannot directly send it to the cloud. So some process has to be done before sending the data into the cloud. And so this process is called data acquisition. So the analog data will be converted into digital data, and some process will be done before sending it into the network layer. And once the data is converted into digital form, then only it will be sent to gateway. Okay, from gateway you can send the data to cloud through various means. It may be Wi-Fi or LAN or some other internet devices to the next layer. Next layer is the third layer, cloud storage layer. Okay, and so basically we have 3 types of components in IoT devices. Devices means the objects as well as sensors and gateway, and then cloud. And based on the information, the direction of information We can classify IoT into three different categories. One is things that receive data and act on it. So it will receive the data. Based on the data received, the devices may operate. Some of the examples are 3D printers, wearable devices, smart TVs. So these are the devices which collects the data from IoTs and then operate. Based on the data, it will operate. The other thing is there are some devices which collects the data and it will send it to some other place. Okay, applications. For applications mean for further analysis or for further processing. Uh, some of the examples are motion sensors, master sensors, and light sensors, which collects the data and send it to the application layer for a decision making. And then sometimes you may have this things that can perform both functionalities. It receives data as well as it sends data. Okay, so one famous example is IoT based farming system. It sends data from the farm as well as it receives after analysis. The output of the analytics will be sent back to the farming place for further action to optimize the process or to improve the process. Okay, and now we will see what is IIoT. IIoT is nothing but industrial Internet of Things. So this is the functionality wise, it is similar to that of IoT, and this is the key technology for Industrial 4.0. And similar to that of IoT, it also integrates instead of normal devices, it integrates smart manufacturing machineries, AI-powered algorithms, and advanced analytic tools. Okay, the main thing is it helps to enhance the machine-to-machine communication as well as it helps to collect and collect the data for further analysis. Okay, so by doing data analysis, you can understand the performance of the factory as well as you can optimize various processes in your manufacturing system, and with the help of power algorithms. So we have more powered algorithms like artificial intelligence and machine learning. So by using these algorithms, you can do real-time predictive analytics. So you can predict the future, okay, by using this powerful algorithms. And so this IIoT, when you talk about IIoT, most of the people think that so it will be it will be useful for manufacturers. Okay, it is not only used for manufacturers. The other side also we can use it. So customer also getting benefits from IIoT. One such example is you may have heard of this tire name Michelin tire, right? So in that, for testing, so they have used different testing protocols. So okay, how they are different from the other tire manufacturers? They have embedded sensors. They have embedded sensors into tires, so which will continuously monitor the behavior of the tires when it is in driving. Okay, when it is on road, it measures the performance or behavior of tires. Okay, by measuring the performance of the tire, it will suggest the drivers. It will suggest the drivers how to drive and how he can save the fuel. Okay, all those things it will suggest. Okay, so this is one example, and so now we are talking about this in the IoT and IIoT for nearly for 20 years. But many of the manufacturing companies started to implement IIoT in their facilities. But we cannot say that all manufacturing industries have implemented this concept of IoT. Okay, and the main reason for uh, the way they have implemented this IoT may be different, but the only reason for implementing this IoT is improving safety, cost savings, improved productivity, efficiency of the system, and then streamlined operations. So this is common for all industries. These are all the reasons for implementing IoT. Okay, so this the implementation of IoT helps the manufacturers as well as customers in terms of it gives monetary benefits. Okay, they can save millions and millions of dollars by implementing IoT in their facility. But we cannot say that all manufacturing companies, most of the companies have started, but we cannot say that it is in saturated state. Okay. So in this slide, you can see the difference between IoT and IIoT, and so most of the concepts are same, but the place where it is embedded is different. Okay, in terms of application, you can say that IoT is used in household and commercial sectors, and IIoT is used in industrial sectors. Okay, in terms of hardware devices, we can say that the sensors are more delicate because in smart homes, sorry, home appliances, in wearables only we can use this kind of IoT. But in case of industrial sectors, the hardwares are more robust because it has to withstand for various operations performed by the machine. Okay, the hardware tend to be more robust. And then in terms of benefits, it mainly used to increase the efficiency of the system, improve the health and safety uh, of the system. Okay, so mainly it is used to improve the customer experience. IoT is generally used to improve the customer experience, and so this is user centric, and normal persons cannot use this. Okay, cannot use this for their personal lives. Okay, and in terms of safety, this IoT is not much sensitive, but this is very sensitive. If anything goes wrong, it will take serious problems. It will lead to serious problems. Some of the applications are given here. This IoT is predominantly used in wearables, mobile phones, and home appliances. And this IIoT is used in heavy machinery, transportation, smart cities. All industries comes in. In industry means health. We can bring this healthcare as an industry too. Okay, and let us start from this IoT application. The first and foremost application is smart cities. Okay, so for generally people for their daily life, generally they look for the basic necessity for people is it may be electricity or gas or some other food. So these are all the essential things for people. But now people are ready to invest more things to live comfortably, more comfortably, and they want to improve their quality of life. Okay, so it is now it is the responsibility for the leaders to provide all these things. Okay, improving the quality of life means they are expecting more in. They want to travel comfortably. They want to have more sophistication, as well as they want to travel more safety, and so the safety, reducing the traffic congestion. So these are all the things people think that those things will improve their quality of life or their experience in daily life. Okay, so some of the IoT devices which is embedded into different infrastructures and comes under the smart cities are buildings, larger buildings, and street lights, water meters, and then traffic signals. Okay, and so mainly the reason for embedding all these devices are in collecting the data and providing some important decisions to provide all these things to improve the quality of life. Okay, so it helps to assess the security conditions by retrieving the data from surveillance camera, so monitoring the social media and monitor the quality of the air. And you can see in lighting system, if you have IoT, then there is no need to go and switch on, switch off. So based on by measuring the sunlight itself, you can it will be automatically switched on and off. And the smart parking system is also one of the application of this IoT in smart cities. So in larger community building, you can see so this IoT will suggest where is the parking space is empty, and it will also measure how long this uh, car is waiting in that parking space, and all those things will be continuously monitored in smart homes. And the next application is in manufacturing. So there are two major challenges which affects manufacturing. One is machine health model. So generally there are many factors which affect the production of the system. There are many factors, you could say downtime, electric power outage, labor problem, and quality issues, and then improper supply of materials. You could say many reasons which affects the manufacturing process. Okay, so we cannot apply IoT for resolving all these issues. We could apply this IoT. We could implement IoT for resolving some issues like machine health monitoring. So you can automatically monitor the machines by using this IIoT. So from my previous experience, I was working in one project. Still, I was working in a company which is 100 plus years of. It was it has 100 plus years. Okay, but still, in 2018 only they started to implement this IIoT. Even it is 100 plus years of life. They have started to implement 2018 only. The first project which I was worked with um, in welding robots. In welding robots, there is a welding tip. Okay, so this tip generally this tip length is 5 centimeters, and so when it reaches this 1.5 centimeter, it has to be removed. Okay, so while you are using, this will be deteriorated, and it will be depleted, and then it will the length of the welding tip will be decreased. So we have to 1 minute.
Yes, well.
So so when it reaches 1.5 centimeter, we have to replace this building tip. Okay. So currently, what actually the current system the current system was. Yeah. So there may be n number of robots. So those robots may be used for different purposes. We cannot say that all robots, all welding robots, the welding tip will the length of the welding tip will come to this 1.5 centimeter at the same time. So based on the usage, uh, some some welding tip may be replaced after 1 hour. Some welding tips may be replaced within 30 minutes. Some has to be. Some welding tips has to be replaced 1.5 hours. Okay. So, but the persons who were assigned to replace this welding tips, they cannot go and check each and every time. Actually, they because when you are changing this welding tip, you have to stop the machine. Okay, so obviously your machine you will have downtime. You have to stop the machine. That will stop the production. Okay, so they will not, and all these process will is linked. It could be a sequence of operations. Okay, so we cannot stop one machine and we cannot operate the other machine. Okay, all machines should operate at the same point in time. So if you uh, so the employees will go and uh, uh, we cannot say that it should be all machines should operate at the same time. The only thing is this person don't have the facility to go and continuously check the length of this building tip. So every 1 hour he will visit that particular place, and he will change he will change the welding tips of all robots placed in that place. Okay, so some 1 hour means some welding tips you can replace after 1.5 hours, but those welding tips also has to be replaced within 1 hour. Okay, so this leads a lot of problem. IoT sensors were embedded into the system, which measures the length of the welding tips, and so everything is connected to the internet, and continuously the data retrieved from the welding tips are monitored, and when it reaches this 1.8, so it is 5 centimeter means when it reaches 1.5, we have to replace it. But the system will intimate immediately to the person when it reaches 1.8 minutes itself. Okay. So by the time the corresponding person will go and he will replace the system. Okay. So so this is one thing, and one more disadvantage they have is they have a system, they have an automated system, and they are able to retrieve the data. And those systems are standalone systems. They have lots and lots of data in their systems, but the thing is they don't have the facility to get the data from outside from the machine. All data is stored in the machine itself. They don't have the facility to retrieve the data from the machine. So that was the one thing, and but now slowly they are trying to integrate all machines to retrieve the data. And so this is one example for machine healthcare monitoring. Okay, so it will automatically intimate the person about this welding tip length. And so the other thing is inventory replenishment. Okay, uh, so So here, a person has to inventory manager has to go and check periodically about the inventory level of the system. And suppose if there is any stock outs, then the production line will stop. So now we can embed different IoT devices throughout the shop floor, as well as we can embed into the warehouse. So this will continuously monitor the system. So whenever the system is finding out that the inventory level reduces to the safety level, so immediately it will intimate to the inventory manager. Okay, so immediately he can raise the request. Okay, so two things are the two examples I have explained. There are many examples are there where we can implement IoT. And the reason for the main benefits that we can obtain through implementing IoT in manufacturing or given care: prevent defects and downtime, maximize the equipment performance, warranty cost, boost the production yield, and enhance the customer experience. So all these things we can do with the help of the data analytics only. Okay, without data analytics we cannot. So all data we are getting continuously, it is retrieving data. Okay, we should have enough storage, and we should have enough technology to process the data, and to predict the time at which that particular device has to be replaced. So all these things we can do by using this advanced data analytic techniques. And in terms of transportation and logistics, so there are many problems still exist in the transportation and logistics. So this is so without transportation and logistics, we cannot perform any manufacturing process. And some of the challenges are in terms of quantity. Okay, so in the upcoming slides, I will tell some example. If you take any manufacturing company, the suppliers, some of the parts may be produced in house, some of the parts may be outsourced from outside. Okay, so if you are getting parts from outside, the parts have to travel through different nodes. Okay, the mode of transportation could be different, and sometimes the mode of transportation could be changed in between some places. Okay, so during that time, the theft may happen. There is no system in the traditional manufacturing system. There was no system to monitor the quantity of items, how many pallets are there, how many containers that we are loading in the vessel, in the ship. Okay, so now by embedding this kind of IoT, we can track, we can monitor the quantity of items in terms of number of pallets and number of containers. And the second thing is quality. Okay, since I told that it is traveling through different nodes, traveling across different nodes. Okay, so the quality may be affected in any places. Okay, suppose if you take the perishable items, perishable item means food items or medicinal items. The quality should be we should taken care uh, with uh, with high critical factor, because if, for example, if you take this perishable items or medicinal items, it should be kept in some proper temperature, right? So there should be a system which continuously monitors the temperature of the product. So if the temperature goes beyond that, or comes below that a certain level, then definitely it will affect the quality of the product. Okay, so now we can embed this kind of temperature sensors which can monitor the temperature of the product throughout the transportation. And one more thing is on-time arrival. So if the production plans generally prepared based on the arrival of no, we can say in the other way. Okay, so based on the production plan, the orders would be raised to the suppliers. Okay, so to successfully implement the production plan, this parts should be reached on time to the manufacturer's premise. Otherwise, this will lead to downtime. Okay, so most of the time, since most of the parts are imported from foreign countries, we may not we didn't have the system to monitor where the actual vessel is, where the actual container is. So now we have GPS and geofence enabled devices which can capture the actual location of the containers or vessels. Okay, so by that, because by receiving those kind of information, so we can do some other plans, alternative plans. For example, if the due date for the particular arrival is coming Monday, and actually by Sunday itself, the part should reach. Okay, Sunday means what is the date? Today is 30, right? 30 means February 31st. Okay, 31st Jan, the part should reach at the manufacturing facility, because to start the production of February 1st, we need this particular lot. Okay, and because of this IoT, if we came to know that two more delays will be, there will be 2 days delay. Okay, so in such case, the manufacturing facility will take a decision for high priority orders. For high priority orders means it will place the order to the suppliers to send the items through air shipping. Okay, to send the items, because now we are in Friday, 2 more days are there. If this manufacturing facility comes to know this, the part will take 2 more days to reach the manufacturing facility. Then immediately it will take the decision to ship those many number of items from the suppliers through air shipping. But it may lead to some cost, but this will not affect the production process on February 1st. Okay, so these kind of things we can achieve by implementing IoT. Okay, and the other benefits are already we discussed. You may feel it is repeating. So I'll go to the next application. Next application is healthcare application. And so now, similar to manufacturing industry, most of the healthcare industries are trying to bring a digitalization. Okay, by introducing this things, Internet of Things. So in the medical industry, we can call these things as Internet of Medical Things. Like wearable devices. So this may not be a wearable devices which are all used by patients. Some devices may be used at the hospital level itself to digitize the entire workflow of the patients. Okay, so some of the reasons for using this IOMT devices are to monitor exercise, the exercise, sleeping patterns, and suggest what kind of workers they can do, what kind of diets they can have. All these things it will prescribe, and it also improves the patient safety in some intensive care units. You can see these devices will help to continuously monitor the various parameters like blood pressure, ECG, all these things will be continuously monitored, and we need not require nurses or healthcare officers to present near the patient. Okay, these system will alert the healthcare officers immediately when anything goes abnormal. Okay, and these devices also help to improve the not improve the air quality, but it will help to sense the quality of the air, as well as it helps to measure the effectiveness of drugs, and it also helps to remind the health workers to refill the medicines. So all these purpose we can use this IoT, and apart from this, uh, it will also provide customized service to the patients. For example, during COVID time, most of the patients who need regular medical care were not able to meet the doctors. Okay, so this already you know very well. So if we have this kind of system, then this will definitely help the patients to directly communicate with the doctors, and then in virtual mode. Okay, they can communicate the doctor in virtual mode, and then they can get the prescription from the doctors. Okay, and it also optimize various manufacturing process um, which produces various medicines, and it will reduce the cost of producing medical items. And the next last application is retail industry. So before 10 years back, this retail outlets generally reach the customers through advertisements, right? So through advertisements only they can able to reach the customers, and to get the expectations of the consumers. Okay, to get the expectations of the consumers, or to get the feedback about the products from the customers, they generally used to have survey methodology. Okay, so they will go for questionnaire and they will ask the consumers to fill the forms. So from that, they were able to understand the customers' behaviors, buying pattern, and then customers' expectations. So all those things they were able to get from consumers through this kind of questionnaires. Now, with the introduction of this IoT and with the help of this digital channels, okay, like social media, now they are able to directly communicate with the customers. Okay, so in the so this will help the retail outlets to understand the buying behavior of the consumers, as well as they with the help of data whatever they are retrieving from the consumers, they will allocate the space to the product in their shelves. So which shelf will be given more, which product will be given more priority to the top of the shelf, like that they will allocate space to the product, space for the product into the shelf. So those kind of things um, they will get to know from this analysis of the data whatever they are retrieving from the consumers, by embedding various RFID inventory tracking chips and Wi-Fi systems and the other beacons. So these things will help them to understand the customer's buying behavior. What is their facial expressions after receiving the particular product? Okay, so this will help to customize their business, as well as this will help the help the retailers to understand their customers. Okay, so what kind of new facilities that we can offer to the customers, what kind of new service that we can offer to the customers, what kind of new products that we can offer to the customers, all those things they can come to know that this with the help of this retail analytics. Okay, and all these benefits we already discussed in all slides. If I summarize, I would say improve efficiency, better human productivity, reduce the downtime, remote control, and increase the security and smart decision making. So now we will see some of the challenges, present challenges in IoT and IoT. Then we will move on to blockchain technology. Okay. So the first challenge is interoperability. So interoperability means we discussed many some use cases, some applications. So in which we cannot say that the architecture of all sensors will be different. Okay, the architectures of the different sensors may be different. Similarly, they may have different protocols to operate the sensors. Okay, so how to communicate these sensors in a common platform? That is one challenge that the IoT has to face. So by introducing this kind of some API calls, we can enable the machine communication, or we can connect different sensors which has different architectures as well as different protocols. Okay, and the second thing is safety, data security. We are collecting data from different locations. We are putting the data. We are storing the data in a common place, centralized servers, and we don't have we cannot give any guarantee to the data theft. Okay, so in cloud itself, we cannot give guarantee that they will keep our data very safely. So the data theft is one of the important challenge that current IoT is facing. And the second challenge is hackers. Okay, so one example for this one is the DDoS attack, that is distributed denial of service. So if you to look at this picture, so this is a traffic. This picture indicates there is vehicles are going in a road, and the capacity of this road is two vehicles. So at any point in time, you can see only two vehicles are there. Okay, so there is no difficulties in this flow of vehicles. But if you see that if there are any vehicles come in this road, then this will affect the traffic. Okay, likewise, the internet has its own capacity limits. Okay, so if there are more number of requests, if there are more number of users are using that particular website, it will completely affect the performance of that particular server or particular website. Okay, so many of the hackers. Okay, suppose if you are thinking that some company A is the competitor for you, you may attack this company, or you may give some discredit to this company by having this kind of service, this kind of attack. Okay, so for that, what actually they are doing is they are unnecessarily creating some request to see that particular website of this particular competitor. Okay, those kinds of through IoT devices. So in smart homes, we can have IoT devices in our TVs, what do you call AC. So we are using many IoT devices in smoke detectors and calling bells. Okay, so they are using many IoT devices with botnets. Okay, botnets. So these botnets are called as botnet. Okay, so these are all nothing but software. These are all nothing but a software program which automatically creates some request based on the instructions written on this bot. It will automatically create some request to visit this particular website. Okay, it will create thousands and thousands of requests to visit this particular website. Then automatically it will create traffic to the network. Okay, so this will affect the credit of this company. And so this kind of attacks are very common in Internet of Things. Okay, so this should be avoided. And there are some bots which helps for customer service. There some the botnet whichever I am talking is, it is a malicious botnet. Okay, so these are the sequel consequences of having this kind of DDoS. The response to the request will be much slower, and sometimes the request may be totally ignored, and sometimes the website is responding very slowly, or it may be unresponsiveness. So these are some of the negative consequences that we are getting because of this DDoS attack. And the main targets for this kind of DDoS attacks are internet shopping sites, online casinos, and some other businesses which offers online. And these attacks are generally origin from IoT devices. That is why I'm talking as a challenge of IoT. So these DDoS attacks are generally originating from this IoT devices, okay, which are embedded by the hackers. And the next challenge is the dependency of centralized servers. So, as we said in the previous slide, we said data is collected. Data is collected from different sources, and it is transmitted through internet, and it is stored in a cloud storage. Okay, it is a centralized server. And so now people are started to implement IoT in all of their business, not only in business, all of their utilities. Okay, we can say that it is utilities. And as the number of IoT devices connected to the server is getting increased, means obviously the maintenance cost would be more, and the infrastructure cost will also be more. Okay, and so there is some limitations for this kind of centralized service. So this is one of the disadvantage of having this IoT device centralized service. And the next one is vulnerable to single point failure. Suppose if anything happens to this kind of server, then we cannot retrieve the data. Okay, so this is one challenge that we have to address. And so the next one is data security. Already we spoke, right? So some of the challenges that we cannot resolve all these challenges. We discussed this interoperability, we discussed the data security, we discussed this one DDoS attack, we discussed about this dependency of centralized server and single point. So we cannot solve all these problems by using blockchain technology. We can resolve some issues. Okay. So now in the next slide onwards, we will discuss what is blockchain technology. By introducing blockchain technology, we will able to address some of the challenges exist in IoT and IIoT in terms of data security, in terms of this single point failures, and then in terms of mutability. Like if you are feeding data into a centralized server, and we don't have any guarantee that somebody will go and change the data. Okay, so those kind of the things we can resolve by using blockchain technology. Actually, this blockchain, now we are implementing blockchain technology to improve the performance of this IoT. But actually, this technology was introduced to support the Bitcoin. Okay. So first, we will see why this concept of Bitcoin came into picture, and then we will see what is blockchain. So, so the Bitcoin was introduced to solve various issues in the current banking system. One is transaction fees. Obviously, if you transfer your money to some of your friends, you incur some transaction fees, right? So whenever you are taking money from ATM, you will incur some transaction fees. Okay, so we are getting more transaction fees. And the next problem with the current banking system is private ledger. Okay, private ledger means private ledger and centralized ownership. It means that you have an account with the bank, and you don't have the facility to meet your transactions. Okay, and if there is, you don't have any control on your transactions. Okay, whatever they are doing, we will not come to know that. Okay, so that is one problem, and the second one is double spending. Suppose if you have 10,000 rupees, you have 10,000 rupees in your account, and you have to give some 20,000 rupees for two of your friends. Okay. At the same day, now as per the current banking system, you can give two checks, 1,000 rupees for A, sorry, 10,000 rupees for A, and 10,000 rupees for B, with a different checks. Okay, but you have only 10,000 rupees. After depositing this check only, these persons will come to know that you don't have enough accounts. Okay, so this problem currently we have. This is called double spending. You can double spend your money. You can give n number of checks. You may have 10,000 rupees, but you may have you can give checks for 1 lakh rupees. Okay, until these persons will go and deposit their checks, then only they will come to know that your account balance is very very low. So this is one problem that we have in the current banking system. And then financial depression. So it means that so now in newspapers you could read many in news like many banks are going in bankruptcy. Okay, what is the reason for that? The persons who are getting loans, they are not able to return back to the bank. Because of that, the many banks are going into a bankruptcy. Okay, so what is the reason for that? There is no transparency in the transaction. Okay, suppose if you take any salaried employees, if they are going to apply for any loan, at least they will take 2 to 3 months to verify all the details. They used to get 6 months of salary. All these things they are getting. Um, all these verifications are done by the bank, but we don't know the reason why the persons who are getting more amount of money as a loan, and they are not able to return back to the bank. Okay, so there is no transparency in the current banking system, and obviously bank fraudulent. So now we are having many of these kind of cases. Somebody may call you and ask you, please tell me we are calling from so and so, and tell me the OTP. We will give you some gifts. Those kind of things are happening. Okay, and all these things are present in the existing banking system, and these things can be resolved by using bitcoins. Okay, so these coins are otherwise called as cryptocurrencies, and the main reason for having this bitcoins are no centralized power. Okay, no centralized power means who are all in the part of this blockchain network. We can consider everyone as a owner of this network. Okay, so there is no centralized power. All stakeholders in the network will be considered as a owner, and there is no private ledger. So whatever transaction you are having with your friends and relatives, so the entire transaction details will be given in a public ledger, not as a private ledger. And so you cannot hack any information as in IoT. Okay, and there is no double spending. So all details will be captured. So we will see those things in the coming next slide. So we can define blockchain as a distributed and decentralized immutable ledgers. Okay, ledger means it contains the list of transactions. Okay, so apart from that, it has other benefits. Distributed means who are all part of the network of blockchain. the transaction, the details of entire transaction will be distributed across the stakeholders of that particular blockchain. Okay, and anonymous. This is other feature of blockchain, anonymous. So in this case, we don't know who are all part of the stakeholders. Okay, so this is one of the disadvantage, but it also has some advantage. Okay, we don't know the personal details of the stakeholders in this network, and each and every transaction, whatever transaction you are doing, everything will be captured with a timestamp. Okay, no one so no so whatever the things we are discussing here, no, so no fraudulence will happen in blockchain technology. Okay, no one cheat others. And anonymous means so suppose if you are if you are doing some transaction, it will not be directly added into a system. So this will be properly validated. Okay. For example, if you want to give check for 10,000 rupees for A and B, before before they deposit this check into the bank, the blockchain system will verify your account details, sorry, your account, your balance, and then it will validate the transaction only when if you have enough enough balance in your account. And immutable means you cannot change any transaction details. So once it is updated into the blockchain technology, it will not be you cannot change it. Okay, you can just view the existing data, but you cannot change anything. But you can append the data. Okay, you can append any transaction, but you cannot change the existing transaction. And all records are very safe, because all transactions will be hashed, not encrypted. It is hashed. Okay, so many hackers, so suppose if they want to hack the data, then they cannot re-engineer the hashed data. Okay, and next one is smart contracts. So most of the things will be done automatically based on the rules and regulations written in the smart contract. So this we will discuss later. And so this is the basic features of blockchain. So now you can combine the challenges of you can just compare the challenges of IoT and IoT with the benefits of this blockchain. Okay, so some of the challenges which exist in IoT system can be resolved by introducing blockchain technology into IoT. Okay, in terms of this centralized server, now we can have a distributed system. Suppose if anything, if any one of the server is getting disturbed, you can retrieve the data from other servers. Okay, and it is time stamped. No one can mute the data, no one can change the data, and it is completely secure because it is completely hashed. Okay, and you cannot the personal details of each stakeholder is kept anonymous, so you cannot know that who is the other participants in the network and all. And most of the transactions you can do automatically by using the smart contracts. Now why it is, we will see why it is called as blockchain. Okay, so blockchain, it is a block, it is a chain of blocks. Okay, it is a chain of blocks, and each block has a collection of transactions. Okay, and so this mainly stores the data in a sequential chain of cryptographic hash linked block. So this is important. It has sequential chain of cryptographic hash linked blocks. So it means that it has sequence of blocks. Each block has a list of transactions, and each blocks is are connected with each other through hash linked blocks. It means that in this picture you can see there are three blocks. There are three blocks, and in each block we have three different and three information. In each block we have three information. One is data. Data means what is the transactional data we have. Okay, transaction. It is not only used for banks. It is used for other than banks also we can use it. We will see the applications where we can use blockchain in the upcoming slides. Okay, it may not be a financial transaction. It could be a inventory transaction, or it could be a stock transaction. It could be any transaction. Okay, and so data means list of transactions. Block hash. So this is the hash code of this current block. Block hash means hash code of the current block, and hash of previous block. So this block, this code, links to the previous block. Okay, so if you look at here, there are three blocks, and you can see there is a block hash. Block hash is the hash code of the current block, and the previous block hash. So with the help of this previous block hash only, you can get the details from the previous block. Okay, and the list of transactions with the timestamp. You can see list of transactions with timestamp. Timestamp is very, very important here. Okay, so these are the three information available in each block. And uh, so before discussing this applications of blockchain, we will discuss how this blockchain secures the data. Okay, so with the help of this hashing function, each and every transaction will be converted into hash codes. Okay, suppose if you are doing some transaction to some other people, the transaction will be converted into hash codes with hash function. Okay, so this is called hashing, and this hash code is a unique code, and you cannot reverse engineering these hash code. Suppose if you want to retrieve the data, you have to solve some complex mathematical puzzle. Okay, so once you solve the complex mathematical puzzle, then only you can retrieve your data. Okay, and the persons who are solving, there are some nodes in the blockchain network, or you can say this may be a person, or this may be automated programs which solves different complex mathematical puzzle to retrieve the data, to append the data. Okay, not changing the data. Okay, you can retrieve the existing data in a blockchain. You can do two things. One is retrieving the existing data, and the second thing is you can append the data. Okay, for these two things, the request will be validated. In case of requesting the data, whatever request you are posting, it will be validated. Once if it is a valid request, then only you can retrieve the data. And in second case, if you want to append, if you are doing some new transaction, so the transaction will be successful after proper validation and verification. Okay, after the successful transaction, the transaction detail will be appended into the existing blockchain. Okay, so for these two things, for validating the request as well as for validating and verifying the new transaction, the miners has to solve a complex mathematical problem. So these miners are the persons or computer algorithm which solves mathematical problems to do these two things. Okay, so once they solve the problem, they will get a solution that is called a proof of work. Okay, which helps to validate the block, whether to append the data or not. Okay, and this hashing is different from encryption. In encryption, you can do reverse engineering by giving a key. You can decrypt the data, but in case of hashing, you cannot do reverse engineering. You have to solve this mathematical puzzle to get the details. So if the hacker is able to get the files, he can get the hash codes alone. He cannot get the actual. He cannot retrieve the data from this hash file. Okay. So because of this hashing, the entire data will be converted into hash code. So it cannot be easily theft by the hackers. Okay. So this hashing makes sure the security or security of your data. And so this picture shows the blockchain. Here you can see there are 4 blocks. And as we said earlier, each block has the hash code of the current block, hash code of the previous block, and the list of transactions. Okay. Suppose if you are currently you are in the 4th block and you want to retrieve the data, the recent block is 4. Suppose if you assume that the recent block in the blockchain is 4, and if you want to retrieve the data from the first block, you cannot skip these 2 blocks. You cannot skip block 3 and block 4. Block 2. You have to go to the block 3 by using this previous hash code. From block 3 to block 2 by using this code, and from block 2 to block 1 by using this code. Okay, sequentially you can go to this block and then you can retrieve the data. you can directly jump from block 4 to this block 1. Okay, and the reason for having more number of blocks is each block has its own limitations. It can have a certain number of records. So once it reaches the record limit, the new block has to be created, and the other transactions will be loaded into the new block. Okay, and so here you can see how the blockchain works. Suppose if you want to transfer money to your friend, the request will be raised. Okay, so the request will be raised. Immediately it will not be your transaction will not be complete. After doing all these process, then only you will get the confirmation of your transaction is successful or not. Okay, so once you raise the request for transaction, and your request will be converted into hash. The request for that amount, particular amount to that particular person will be converted into hash, and there are set of miners, and this your request will be broadcast into the miners of your network. Now you are a stakeholder of a blockchain. There are many people like you in the blockchain, and if you want to transfer money to one of your friend who is also a part of this network, and once you initiate the transaction, immediately your transaction will be converted into hash code, and this hash code will be broadcast to the miners. These are all the persons who are validating and verifying your transaction. Okay, and this will be broadcast to the different miners, and so all miners will try to solve the puzzle to understand whether your transaction is valid or not. Okay, whether you have enough money or not, whether the person B is there or not. So all these verifications will be done by this miners. So for this thing they have to solve a mathematical puzzle, and then once they identify the solution, or once they identify the hash code, okay, details of the hash code, then so the solution, whatever they are getting, right, whatever they are getting after solving the mathematical puzzle, that is called a proof of work. Okay, then this proof of work will be attached to the actual request raised by you, and suppose if there are 100 miners are there, if there are 100 miners are there, the request will be broadcasted to all the miners. Okay, and all miners will try to validate your transaction. Okay, and the one who first validated your transaction means who is able to solve the mathematical puzzle, and if they are able to identify the solution for that puzzle, they will attach the solution along with your transaction. Okay, and the rest of the other miners, they will validate your proof of work. They will validate your solution, whether the solution is correct or not. Once they validate the solution, then only they will acknowledge your transaction, and they will give verification. So then only your transactions will be completed. Once the transaction is completed, then the transaction will be appended into the blockchain. Okay, then transaction will be appended into the blockchain. For example, suppose if the miners want to know your account details, the miners want to know your account details. You are sending request for 10,000 rupees, transaction of 10,000 rupees. So your transaction will be valid if you have enough balance in your account. So to retrieve the details of your account, they have to see the account details. For seeing the account details, they have to find out the password for your account details. So through your request, you will not directly give the password to the miners. Some hash code along with your request will be generated, right? So in that hash code itself, they have to find out the password. So they have to convert the hash code. For converting the hash code only, they have to solve the problem. For example, I say that the password consists of 4 digits. Okay, 4 digits. Digit 1, digit 2, digit 3, and digit 4. For example, if the password, the summation of 4 digits would be 32. Okay, I can provide any number of combinations. To simply, I'm saying that it consists of 4 digits, and the summation is 32. It could be any sequence of any pattern. Okay, it could be any pattern. It may be 0 0 0 32, or it may be 2 0 0 30, or it may be 1 31 0 0. So any pattern, but you have to give exact pattern to retrieve the data. So the work of the miners is to find out the exact pattern of the password. Now I hope you understand what is this proof of work and what these miners are doing. Okay, all patterns will give this satisfy these two constraints. It could be 4 digits and it could the summation could be 32. But we should identify the exact pattern of your password. Okay, the miners are doing this only. They will find out the exact pattern by solving the problem, and there are so they have to develop some algorithms to find out the exact pattern for the corresponding hash code whatever they are receiving. Okay, for the hash code whatever they are receiving, they have to get retrieve the password details from the hash code. For that only they have to solve the algorithm. Okay, once they find out the hash code or pattern of this password, that is called a solution that will be attached to the transaction, and other miners, the other remaining 99 miners, they will verify the password. If it is correct, then only your transaction will be completed. Okay, if the transaction is completed successfully, then the transaction data will be attached to the existing blockchain permanently. You cannot modify it. It will be attached permanently. Okay, and so now I hope you understand how the blockchain works. And so these are the technologies for blockchain. One is private key and private key cryptography. So this is similar to that of mail ID and password. Suppose if you want to send a mail to one of your friend, you should know the mail ID. Then only you can send mail. But you need not know their password, right? Similarly, by using blockchain, if you want to send any transaction, you should know the ID of the your ID of your friend. ID. Okay, ID of your friend, and so this is called public key. The ID of other members is called public key, and password is called the private key. Okay, and the second technology is the P2P network. Suppose in this picture you can see this Andy. He transferred $10 to Bobby, and Bobby transfer $3 to Derby, and Derby transfers $1 to Cindy. All these persons are in the same blockchain network, and in this case you can see all these transactions, whatever transactions that happen between Andy and Bobby will be able to visible by this Derby. All these transactions will be, so this is called a decentralized ledger. Okay, decentralized ledger means all transactions done by all participants in the blockchain technology will be distributed across all stakeholders. Suppose if anything happens to Andy's server, the other three persons can retrieve the data from, the Andy can retrieve data from either Cindy, Derby, or Bobby. Okay, so this is the advantage of having this blockchain technology. Okay, and the last thing is smart contracts. We will see some examples on smart contracts in the upcoming slide. So in this slide, you can see the different types of blockchain. One is public blockchain. Okay, public blockchain means anyone can join in the network. Anyone can join the network. Anyone can transfer, do transactions in the blockchain. Okay, one of such example is Bitcoin. The second type of blockchain is private. So in which only a specific people of that particular organization will be part of this blockchain network. Okay, and uh, 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 so the people, the stakeholders of the blockchain are allowed to view the transaction data. And the third type is only group of organizations, group of different organizations. So you should understand the difference between this private and consortium. So in private, within the organization, the blockchain will be formed with the specific people within that particular organization. And consortium is nothing but different organizations will form a blockchain. Different organizations. Okay. So one example is banks. Different banks can form a blockchain. And the fourth one is permissioned blockchain. So in which within this organization, you can form a blockchain, and here customization options are there. Okay, so, there are certain stakeholders may be allowed only to view the transactions. Okay, there are certain participants who can do transactions. Okay, So here the privilege will be given to the stakeholders of the blockchain based on their position. Okay, based on their position. So if you are in managerial level, then you will be allowed to do transaction. Okay. Suppose if you are a developer level, then you can able to you can only view the transaction. So based on the positions of the stakeholders of that company, okay, of that company, the options are customized. Okay, whether you can only view or whether you can do transaction. Okay, all these privileges will be given based on the position of the stakeholders. So these are all different types of blockchain, and so these are all different. Stop me if I'm running out of time. I'll continue until the time. You can see different blockchain use cases here. So this is used not only in financial services, it is also used in other services, banking, healthcare, law enforcement, real estate, online music. One of such example is implementing blockchain concepts in Internet of Things. Okay. So from next slide, we will see some of the IoT and blockchain use cases. And so all some of the things, some of the challenges we discussed will be definitely resolved by blockchain technology, by introducing blockchain technology into IoT implementation. So those things are listed here. I will skip this. Already I discussed these things. Um, so now come to the smart contract. This is one of the important concepts in blockchain technology. So contract. What is the meaning of contract? It is the agreement between two or more parties. Okay. So here rules and regulations will be developed based on the agreement of different parties in the blockchain network, and so based on the rules defined by those parties, most of the operations will be automated. Okay, so that is called smart contract, and this is a program. This is a computer program, and based on the approval from the stakeholders of the blockchain network, some rules may be defined, and it will be written as a computer program, and it is it is deployed in blockchain network. Okay, and it automates most of the process, and you cannot mute the smart contracts. It means that once the rules are defined by all the stakeholders in the blockchain, no one can change the rules. Okay, once it is written and it is deployed in the blockchain network, it will be automatically do the process. Suppose if you want to change the smart contract, you have to deploy a new smart contract. Okay, you cannot go and change the rules whenever you want. Okay, and the advantages of having smart contracts are cost saving, speed and accuracy, transparency and trust, and security and storage. All these are advantages of having smart contracts. And some of the limitations, even though we have many features, many good features in blockchain, there are some limitations in terms of complexity of understanding. Okay, so I talked about this mining, hashing, proof of work. So common people won't understand this kind of terms. Okay, in terms of understanding, it is complex. Uh, they are not able to solve mathematical solutions. Okay, so only the persons who are able to solve the problem by writing complex algorithms only they can use it. And the transaction cost is similar to that of current banking system. For each transaction, we have to pay cost for the miners who are all involving in the blockchain technology. So they may play two roles. Either they may play as a miner alone, or they can be a part of the stakeholders, a part of the network. For each transaction, we have to pay money for the miners. Okay, but the transaction fee is less compared to the existing bank transaction, and obviously network speed. So if you are using internet for transferring too much of data, obviously it will affect the efficiency of the network as well as human error. There could be possibility that the miners can do some mistakes. Okay, the miners can do some mistakes, and then unavoidability of security flaw. Okay, so in the previous this slide, I said that if there are 100 miners, any one of the miner can quickly solve the problem and come up with a solution about the hash code whatever they are receiving. Okay, and this solution obtained by one miner has to be validated by 99 miners. Okay, suppose if you assume this case, um, there are so this transaction will be validated if 51 minus 51 and 49, the maximum limit, at least 51 minus has to accept this proof of work. At least 51 minus has to accept this proof of work. Otherwise, this particular transaction will not be considered as a verified transaction. Okay, so that is called as consensus. Consensus from other miners. At least 51, you have to get vote at least from 51 miners. Okay, so this is called this 51 percentage attack. Sometimes purposely, suppose if the proof of work may be a correct one. Suppose if 51 miners said that your proof of work is wrong, and 49 miners are saying that your proof of work is correct, then obviously the majority of vote goes to the proof of work, whatever you have developed is wrong. Okay, so this kind of problem may occur. That is called 51 percentage attack. Okay, and less people awareness, and then one more thing is lack of confidence. Confidence. This is one of the major disadvantage or limitation of blockchain concept. And some of the use cases we will discuss. First and foremost is supply chain and logistics. So before that, let us define what is supply chain. Supply chain is the system of suppliers, manufacturers, distributors, retailers, and end customers. So it has many players. So in any common supply chain may have these entities or elements. Okay, and so you can see in supply chain, you can have information transaction, money transaction, and then product transaction. Okay, information transactions means information about the price of the product, information about the demand of the product, and the flow of money will happen once the request reaches to the suppliers. In the downstream, the flow of money may happen, and the flow of material may happen from suppliers to the end customers. Okay, so this is the generic supply chain. And in this case, I assume the 5 different stages of the supply chain. Sometimes you may not have this distributed, sometimes you may not have retailers, sometimes the manufacturer can directly send the product to the end customers. Okay, so now there are many challenges exist in the supply chain. So I will talk this concept of IoT and blockchain in the context of supply chain and logistics. Okay, there are many challenges exist in the supply chain. The first one is end-to-end visibility. The second one is delivery delays and lack of transparency. So I have listed only 3 challenges here. In the upcoming slide, I will talk more about it with one example. So if I explain with one example, then you will be able to realize the use of IoT and blockchain to address the various challenges. Okay, and some of the IoT devices, majorly these IoT devices are helps to track and monitor various process in the entire value chain. So this is called entire value chain from suppliers to end customers. So you can embed IoT in all these stages, and you can monitor the process throughout the supply chain or value chain. Where several devices are used, like GPS, temperature sensors, connected devices. All these things are utilized to monitor all these things. And one such example is Golden State Food. This is a company which delivers food to different outlets. Nearly 125 restaurants they are distributing food items, and along with IBM, they are using the blockchain technology with IoT. Um, and so I'm going to explain this concept with automotive industry only. So let us go to this one. So here you can see the various stages of a supply chain in the automotive industry. Okay, so here this is a manufacturing facility. This is a manufacturing facility. They are receiving parts from different suppliers, and after producing the parts, they are delivering parts to different dealers. From dealers, the here products are nothing but cars. Okay, products are nothing but cars. The cars will be delivered to the customers, and the customer, based on the requirements of the customers only, the cars, most of the cars will produce. Okay, so if you look at here, I missed one thing here. First I will draw this point. this manufacturing facility. So if you look at the flow of product, flow of process. Okay, first first it will start from blanking, blanking, blanking. The second stage is stamping. I'm talking about this manufacturing facility alone, stamping. And third one is body shop. And then the parts will go to assembly shop. I'll explain why I'm drawing this picture. Here we have moving assembly line. Moving assembly line. And here there is an engine shop. Engine shop. The parts will come from engine shop to this moving assembly line. So here all assembly will be done in assembly shop. Finally, you will get the cars to the yard. So this is the way how the flow of the production of cars happens inside the manufacturing facility. So in blanking, steel rolls will be provided as the input. Steel rolls. Okay. So in this particular manufacturing company, the products which are made in house are only body parts. Only body parts, and the remaining parts. Apart from body, we have in assembly itself. Generally, the car is manufactured by using 30,000 parts. Okay, by using 30,000 parts, we are producing a car. Only body parts are produced in house. The rest of the parts are purchased or outsourced from other suppliers. And engine parts. So for many engine parts are also outsourced from other suppliers, and just assembling of engine as well as the other customized products are happen in this moving assembly line. So this is the flow what is happening inside the manufacturing facility. So I told that 30,000 parts they required to manufacture a single car. Okay, so they depends on powertrain suppliers. Powertrain is nothing but engine. Powertrain. So there are many parts are required to assemble engine, right? Similarly, they require. I have listed only five suppliers, five important components: seat suppliers, tire suppliers, glass suppliers, and electronic items. Whatever electronic items we are using inside the car, all these things we need most of all these things are outsourced from the suppliers. Okay, so here I'm going to talk about the different challenges existing in this automotive supply chain. So before that, you should understand the flow of the supply chain. Okay, how the flow happens in this automotive supply chain. So this is called as tier 1 suppliers, who are all direct in contact with the manufacturing facility. Okay, and for this powertrain suppliers, they may have their own suppliers, component suppliers. Similarly, for seat also they may have their own suppliers. They may have n number of if you take any supply chain, it may have n number of tier 2 n number of suppliers. Okay, parent suppliers, tier 2 suppliers, tier 3 suppliers, tier 4 suppliers. There could be n number of parent suppliers. Okay, the problem here is the visibility of the supply chain, visibility of the suppliers. What do you mean by visibility? So if you take this manufacturer alone, he may know his own powertrain suppliers. He may not know who is the supplier for this powertrain. Okay, he may not know who is the supplier for this seat supplier. So up to this level, he may have the visibility. Okay, actually this problem raised during this COVID period. Okay, so during December there was no problem with the manufacturing at this particular manufacturing industry during December. During January, actually one example is for this particular manufacturing company, the location of the glass supplier is Bangalore. Okay, the location of the glass supplier is Bangalore. But for them, the supplier is in China. Okay, till January there was no problem. After January, they were not able to supply glass to this manufacturer. So during that time only, they came to know that the supplier of this glass is located in China. So till that point in time of last year January, they didn't even know that who was the supplier of this glass. I'm saying only one example. You can extend this example to all other cases. Okay, because of this lack of visibility. Okay, So because of this, till Jan, Feb, March, April, they were not able to. So in India, lockdown happens in at the end of March only, right? But still, they were not able to continue their production from January itself because of this lack of production, sorry, lack of visibility. Okay, lack of information available about their preceding suppliers. Okay, so we should have a system where we can collect the data about their parent suppliers. So if we have such a system, then obviously this manufacturer has taken some other precautionary measure or some other alternative measure to continue the production for these 3 months, Jan, Feb, March. Okay, so this is one problem in automotive supply chain. So this could be addressed by introducing blockchain. And the second thing is transparency and immutability. There are many problems. Okay, so I will rub it. So in the supply chain, I'm talking only about this manufacturing plant alone, but to support. So there are, if you look at here, there are look at the complexity of the supply chain here. Okay, there are many parts are coming from outside. Okay, to manage all the activities, you can see here these are all many departments which support this manufacturing facility. Then you can take design department, manufacturing operations department, supply chain and logistic department, purchase department, human resources, and so there are many departments which support this manufacturing process. Let us come all these points one by one. The second point I have taken is transparency. Okay, transparency means I have taken one example. This is a container loading problem. So as you know that the container loading problem is nothing but based on the based on the part requirement, you have to calculate the number of containers required. Okay, so here the parts are outsourced from the suppliers, foreign suppliers daily. But suppose if you want to produce use items for today's production plan, for this to satisfy today's production plan, 2 months ahead itself you have to place order. If it is a foreign suppliers, at least 2 months back itself you have to place an order. Okay. For that there was one problem to determine the number of containers, because if the container is half loaded level, or it is suppose if you are ordering only 10 pallet loads, for that also we have to pay the full container fees. Okay, so they incurred more cost in renting containers from the suppliers. So we wanted to optimize the number of containers required to reduce the cost. Okay, based on the actual requirement, what could be the number of containers required? Okay, so there is one system called materials management system. In that system, we can have details like part dimensions, part dimensions, quantity, and status. Status also we have whether this part is active or not, active or inactive, and how much quantity is available, and how much quantity is ordered, and other transactions details may be there. Okay, generally we calculate this container load based on the quantity of material required, and for each quantity corresponding dimensions will be calculated. This is the 3D container loading optimization problem. So based on the dimensions and based on the quantity, we used to forecast the containers request for that particular shipment. Okay, and at one when we have developed an algorithm. When we run an algorithm, when we develop an algorithm, the part dimensions may be something. Okay, after 1 month period of time, because this is a common material management system, all people can access this. Anyone can change the data. Okay, anyone can change the data. So suppose if I develop an algorithm today and I give the number of containers today based on the dimensions written on that particular day. Okay, for example, as I would say 56 containers based on the dimensions whatever I see from the materials management system as of today. Suppose if they take the data tomorrow, and tomorrow the dimensions may be changed. Because of that, the container may increase from 56 to 58. Okay, so there will be two difference. So this will increase the cost. Immediately they will ask us why this container you are saying that 56 and we are getting 58. So when the same algorithm is run by the customers of the same company, they may say that 58, but the developer would say that on the day of development it said that it is 56 because that all has the accessibility to change the data, but it should not be like that. Okay, so somebody if anyone change the data, then it should be properly intimated to the developer as well. Okay, so here the immutability is very, very important. No one can go and change the data just like that. Um, so how long I can extend?
Ma'am, how many minutes you want further, ma'am?
I will try to complete this one. Huh? I'll take 10 minutes.
Yeah, yeah, please. Okay.
So this is one example for which emphasize the importance of this immutability. And the other one is I will skip all these use cases because of this time constraint. And the other case, I plan to explain all these use cases, but okay. The next use case is traceability. Okay, traceability in terms of quantity and quality also we will discuss. So I said that there are 30,000 parts. For this manufacturing facility itself, there are 30,000 parts. There are many suppliers, and there are for them also they have many parent suppliers. Now I will take this leg alone. I will take this leg alone from tire supplier, from powertrain supplier to this manufacturing facility. This leg can be expanded like this. So they cannot directly send the products to the manufacturing facility. They cannot send directly to the manufacturing facility. There are many players are there who helps to transfer the items. If the suppliers are a big larger suppliers, they can directly send the items to the manufacturing or OEMs, but they cannot send means they cannot directly send from here to here. They have to get approval from all these stakeholders in this logistic chain, and then only we can get the product. We can receive the parts. Okay. Some small suppliers, no, some small suppliers, they cannot send the items direct. They cannot send the items through a single container to this OEMs. So instead, they will supply the items to the lead logistic providers. Here, there are many suppliers like this. Okay, many suppliers for different products, different companies. So these lead logistic providers collect all these items, and they will do all formalities in terms of money and in terms of all formalities they will do, and then they will transfer the items. So here some trucks the items will be unloaded, and it will be again loaded into a container, and then it will be sent to this ocean carrier or ship. Okay, ocean carrier or ship. After verifying all the customs formalities, then it will take travel through the ship or ship, and then it will reach the place where all customs will be done. Then only all the container items will be unloaded into a truck. Okay, from ship it will be unloaded into a truck, and the trucks will carry the items to the manufacturing facility. So here I have simply put one leg. So look at the complexity of the process. Okay, look at the complexity of the process. It has to cross many players to reach here. Okay, so here anything may happen for the product. Anything may happen for the product. Okay, it could be theft, or they can exchange with some other products. Okay, anything may happen, and this IoT and blockchain will help to understand to monitor the product from supplier to this till this point continuously, and all data will be taken care by this blockchain. Okay, if anything goes wrong, it, with the help of blockchain, you can identify that in which place that particular defect happens. Okay, it may happen in the supply itself, or it may happen in the lead logistic providers, or it may happen in the ship. It may happen anywhere. If you have only IoT, you can track the number of theft alone, number of quantity alone, but you cannot find out where the particular defect happens. Okay, those kind of things you can done with the help of blockchain technology. Not only in terms of theft, some people may exchange the product. So those kind of things will also be taken care. And then in case of warranty claims, the suppose if they find now the smart contract comes into picture. Okay, if they find any problem in any one of the place, automatically the smart contract will trigger and send back to the items. From that place, it will send back to the items. Okay. So, so these are all the challenges and how the blockchain technology, uh, how the blockchain with IoT, sorry, IoT with blockchain will address all these problems are discussed. And so this currently I'm working on this blockchain framework for addressing all these challenges. And some of these, my example for smart contracts are inventory replenishment. Once you, with the help of IoT, you can continuously monitor the inventory level. With the help of smart contracts, once it reaches the predefined level, automatically the order will be raised to the concerned suppliers. Okay, that is one example for smart contracts. Similarly, digital payment. Digital payment means once you raise the order, or after finishing all the process, once you receive the exact order whatever you have placed, once you receive the order, the payment will be done automatically once you receive the order. Okay, so these kind of things you can implement by using smart contracts, which you can deploy in the blockchain technology. Similarly, you can do return of the defective parts. If you identify, if the blockchain identifies that if there is any defect in any of the stages in the value chain, it will be automatically returned back to the suppliers. Okay. So this is a smart home. Already we discussed the application. Here is what is the role of blockchain. Here is in smart homes we are sharing our personalized data. So it may be checked by some other people. So if you share the data with blockchain, it will be completely secured. Similarly, sharing economy is another concept which we can use both IoT and blockchain. So here the asset can be shared across many people to increase the return. Okay. And in pharmacy industry also we can utilize this IoT and blockchain. The thing is, in pharmacy industry, in supply chain of the pharmacy industry, when the items are shifted from one entity to other entities, the ownership may be different. So they may have different names. Okay, suppose if anything happens wrong in the items, whatever we are procuring, medicinal items we are procuring, so this blockchain technology will help you to identify and track where that particular defect happens. There are many players in the value chain, so it will exactly find out in which place we got these kind of defects. Okay, defect. One of the example for defect is not properly maintaining the temperature of the medicine. In agriculture also we can utilize this IoT and blockchain. In terms of farming also we can use. In terms of supply chain, in agri supply chain also we can use it. Okay. So this role of data analytics, obviously you cannot separate this IoT from data analytics. Without IoT, you cannot get this data-driven solution. Okay, there are many types of data analytics are there: descriptive, diagnostic, descriptive. So from the data, it will tell what has happened. Okay, diagnostic analytics will tell you what is the reason for that particular event, particular incident. Similarly, predictive analytics, it will say you based on the data, whatever it is collected from the devices, it will predict the future. Okay, and this prescriptive analytics is nothing but your this optimization, various optimization algorithm. So from the data, it will come up with various courses of action, and it will suggest you which course of action will be better. And this streamlining analytics, this is very important for this IoT devices, which helps to continuously monitor the data. Okay, so in case of this logistics, it will continuously monitor the GPS data by which you can position the location of the product. Okay, parts. And this spatial analytics is also one. This also helps to position your location of the product. And so I will wind up with this. And so so from this talk, I think you will realize the benefits of IoT and blockchain in industries, in various industries. Till now, we have not implemented this IoT, Industry 4.0 in many industries. But now itself, we started to talk about Industry 5.0. So here we are going to bring back the intelligence, human intelligence to improve the performance of Industry 4.0. Okay. So with this, I'll stop my presentation. I'm ready to take your questions. If you have any doubts, you can ask me. Otherwise, you can send me mail.
Madam, thank you so much. Thank you so much for your excellent
Sir,
session.
but I'm due to time
So,
constraint,
you
I'm unable.
lot of information, have been
So due to
provided.
time
So I
constraint, I
hope
am
this
unable to complete
enhanced.
my some of the use cases I skipped.
Yes, no, I understood.
Yeah.
Understood. No, understood. Yeah, yes,
Uh,
no. Yeah. Thank you so much. And so this might have given some very good enhancement in knowledge of the participants. So thank you so much. And participants, those who are willing to ask the questions, please you can either text in the chat box or you can raise your hands, by which we will be allowing us to come and interact in the live session.
or you can send me mail as well.
Yeah, or you can.
Kalpana at AAC.in. You can see my mail.
Yes, ma'am. Yes, ma'am.
You can contact me at any time.
Yeah.
Can you see my mail ID?
Yes, ma'am. I hope there is no question from their side, and so thank you, ma'am. Thank you.
Thank
We
you,
would
sir.
like
Thank you
to.
for this opportunity.
Yes, ma'am. We would like to hear you a lot from some other webinars. Thank you.
Yes, thank you, sir. Thank you.
Thank you so much.
Okay.
Participants, thank you so much. 1:30 we will have validatory function. So we will have some 10 or 15 minutes about validatory. We will get some feedback from participants and we will finish the function, finish the FTP formatting. Then I will give you a Google Form link. So you have to attend the quiz. Okay. So once the validatory function is over, the quiz link will be shared. So you have to attend the quiz. Okay. So please, we'll meet at 1:30. I hope you'll be able to come. You'll be able to come back. So we'll meet at 1:30 at the validatory function, and the test will be of 20 questions. We have 20 questions and multiple choice questions, MCQ questions. So I hope almost most of you might have maintained 80% of attendance, and the test also you need to score 60% of marks. So since MCQ, the questions all will be from the sessions what you have heard in the past 5 days. Hence, you do not need to worry. So if you listen the session well, so we will meet at 1:30. Thank you. And if anybody is interested to share his or her feedback in coming to live, so please you can text me personally in the WhatsApp. I will share the link so that you can come in online and you can register your feedback in the session. Thank you. Thank you so much.